we're going to take a look at the unit circle and how it's going to organize for us what we already know about some of the angles that we use in trig, which I like to call the golden angles, and how it allows us to kind of organize all this data and figure out some more information about other angles that are connected to these. Now, what I call the golden angles, which I've totally made up that word, is 0 degrees, 30, 45, 60, 90, 180, and 270. Now, at this point, you should know all 6 trig functions for these 7 angles, okay? And we do that by 4 of them are axis angles, so we pick a terminal point, and 3 of them, the 30, 45, and 60, we use the 45, 45, 90 triangle, and we use the 30, 60, 90 triangle to do that. So what we're going to do now is we're going to use this circle to help us organize all of that data. So let's first remember that the unit circle has radius 1. So the easiest thing to do is to pick the points, the endpoints of the circle. So I know for sure, since it's a unit circle, this is going to be 1, 0, because the radius is 1. At the top, this is going to be 0, 1. Over here, it's going to be negative 1, 0. And over here, it's going to be 0, negative 1. Okay, let's start labeling next some of the angles. And I'm going to write them in degrees and in radians, because when we start graphing, which is the next step in trigonometry, we're going to be using radians. So the first, obviously, here is going to be 0 degrees, or it is also 360 degrees. In radians, that is 0 and 2 pi. Now, the one at the top where 0, 1 is, that is 90 degrees, or in radians, it is pi over 2. Over here on the left, on the negative x-axis, this is going to give me 180 degrees, or pi. And over here, this is going to give me 270 degrees, or 3 pi over 2. So already, right, so what we want to remember here is that in the unit circle, why this is such a great tool, is that for any point on the unit circle, the x is the cosine of the angle theta, and the y is sine theta. So just by looking at the axis angle, if I want to know cosine of 90, that's the x-axis, it's 0, which we already knew. If I want the sine of 270, that's negative 1, which is the sine of 270, the y value. Okay, let's do so already we've covered 4 of our golden angles. Now we need to do the other 3, which is in quadrant 1. So that's going to be 30 degrees will come first. In radians, that is pi over 6, because it's a 6 of 180. Then this is 45 degrees. In radians, this is pi over 4, because it is a fourth of 180. And this is 60 degrees, or in radians, it's pi over 3, because it's a third of 180. Now, what do we know? We placed the 45, 45, 90 and the 30, 60, 90 in the unit circle in the previous video. And we already know the cosine and sine of 30, 45, 60. So the cosine is 1/2. Square root of 3 over 2. And the sine is 1/2. For 45, they're both radical 2 over 2. And for 60, the cosine is 1/2, and the sine is radical 3 over 2. Okay, and of course everything is positive here because in quadrant 1, the x-coordinate is positive and the y-coordinate is positive. So how do we fill out the rest of this circle? And this is really when it comes down to, you do not need to memorize the rest of the circle. Everything depends on the 30, 45, 60 that you already have right there in quadrant 1. And what we do is we use reference angles. Now remember that reference angles is the distance from the terminal ray to the closest x-axis. So I'm going to take a look at this point right here, the one in quadrant 2 that's closest to 180. And that is symmetrical to the other one in quadrant 1, which has an angle of 30 degrees, right? They are symmetrical there. So I know that the reference angle to that angle is 30 degrees. But if I was at 180, so I'm looking at this measure right here. If I was at 180 and the reference angle is 30, I can do the math backwards and I can figure out that the angle is 150. So the only way that it can be is 150. Now, I'll do the radian measure in a second. Okay, next I'm going to look at this angle right here. Ooh, can't write with the eraser. The reference angle is 45. So if I want to go to 180 and I've traveled 45 degrees, I think backwards, 180 minus 45, and that's 135 degrees. And then I have my last one, which I'm going to go all the way to the top, and that one has a reference angle of 60 degrees. Okay, well, it's 180. I'm traveling 60, so that's 120. Okay, how do I write these in radians? Very easy. 150 degrees is 30 degrees times 5. So I'm going to write this on the side one time for you. I know that 150 degrees is 5 times 30 degrees. But 30 degrees is pi over 6. So what's 150? 5 pi over 6. So easy. No need to memorize. 135, that one you might not see right away, but it's okay. 135 is 3 times 45 degrees, so that's going to be 3 pi over 4. You can also see it visually because 45 degrees is a quarter of the way in. So if you do 1/4, then another quarter would put you at 90 degrees, and then another quarter would put you at 135. And then 120 is 2 times 60. 60 is pi over 3, so it's 2 pi over 3. Oops. Actually, let me write this over here so they don't look all together. So 2 pi over 3. Okay, well, what about the coordinates? Again, the coordinates, right, the points are symmetrical to the points in quadrant 1. However, when you flip them over to the other side to quadrant 2, what happens to the x's? The x's become negative. The y's, they stay exactly the same, the y's, but the x's are negative in quadrant 2 and the y's are positive in quadrant 2. So because that red dot, right, the red one is symmetrical to the red one over here, it has the same values except the x will be negative. So that's going to give you negative square root of 3 over 2, comma, positive 1/2. Same thing for 135, negative radical 2 over 2, comma, positive radical 2 over 2. And 120 is going to be negative 1/2 square root of 3 over 2. So as long as you know that 120 has a reference angle of 60, and you know the values for 60, then you know the values for 120. You just have to remember that 120 is in quadrant 2, where the x is negative. We do the exact same thing for quadrant 3 and quadrant 4. So we're going to do it just a little bit faster this time. So the first one is going to have a reference angle of 30 degrees. I start at 180, but this time I'm adding 30 degrees. So this is going to give me 210. Now 210 is 30 degrees times 7, so it will be 7 pi over 6. Now the next one will have a reference angle of 45 degrees, so 180 plus 45 is 225. 225, again, that is 5 1/4. So you've gone 1/4 to 45 degrees, 2/4 to 90 degrees, 3/4 to 135, 4/4 to 180, 5/4 to 225. So it's 5 pi over 4. And then if I have a reference angle of 60, 180 plus 60 is 240. 240 is 4 times 60 degrees, so it will be 4 pi over 3. Now, the reference angle, right, whichever one share the reference angle, they will have the same coordinate, but now I am in quadrant 3. And because I am in quadrant 3, x and y are both negative. So if I take a look here, right, the point at 30 degrees is square root of 3 over 2, comma, 1/2. 210 has a reference angle of 30 degrees, so it has the same values, but now they're both negative because I am in quadrant 3. And it's the same thing for 225, negative radical 2 over 2, comma, negative radical 2 over 2, and the same thing for 240, negative 1/2, because now it has a reference angle of 60, and negative radical 3 over 2. All right, let's do the last quadrant, quadrant 4. Now remember that when you do your reference angle in quadrant 4, you're going to 60 degrees, right? You're no longer going to 180. So if I'm going to 360 and I have a reference angle of 30, I'm subtracting, right, because I'm going lower. So 360 minus 30 degrees tells me that this angle is going to be 330. Now 330 is 30 degrees times 11. So that's going to put me 11 pi over 6. Because 3 times 11 is 33. Then if I have 45 degrees, 360 minus 45 is 315. Now you have gone 7/4 of the way, so it's 7 pi over 4. It's 45 times 7. And if I have 60 degrees, 360 minus 60 is 300. And 300 is 60 times 5, so that is 5 pi over 3. Now you just look at their reference angle, but now in quadrant 4, which coordinate is negative? The y coordinate is negative. So at 11 pi over 6, which is 330, it has a reference angle of 30, so it will have the same values as that blue circle I have, but the y will be negative. So square root of 3 over 2, comma, negative 1/2. Then this one will be a positive radical 2 over 2, comma, a negative radical 2 over 2. And last but not least, this will be a positive 1/2, comma, negative radical 3 over 2. So for example, if you are asked, okay, what is the sine of 300 degrees? All you need to remember is that 300 degrees has a reference angle of 60. It is in quadrant 4, so that will be a negative, the same value as the sine of 60, which is radical 3 over 2. The unit circle just organizes this into one area, and then it helps us actually figure out, kind of visualize some other properties of the trig functions, which is really our goal, because we wouldn't even need really the unit circle. You could just be using this, right? You don't need to really write the unit circle, but it allows us to kind of visualize some of the properties that will be covered in some of the next videos.